Okay, good morning to you. Am I audible to all of you?
Very good morning, ma'am. You are audible.
Yeah, I'm audible, right. So it's time to start. So I wish you again health and everything best. So I hope all of you are doing good. And maybe few students they have joined, and maybe few students they will join with PhD and other students. So what will happen? You can mail me your mail ID so that I can send the link to all of you. Till the point you have not been added to this group mail ID. Actually, the subject code is EEN 672. So this IIT, I mean the administration block in the Dean Academics block, they have made actually one group ID, that is EEN hyphen 672@iitr.ac.in. So when all the students will do the final registration, so all the IDs are going to be added to that group. So till that point, whoever not added, so I send individually the next links for the class. So anyways, I welcome to all of you to the second class of my subject Smart Grid. That is an elective course basically, and 4 credit course. In fact, yesterday I have taken one class. This is the second class, and today and next I have Friday again 12 to 1. So I'll take the same. So we are in the first phase of this course. So let me take just arbitrarily. I'll take, as I said, is just for knowing that how many of you are present. That's all. Nothing else. It is as I said, the interest is within. A single attendance cannot bound your interest, right? So for a particular subject, if you're interested to know something, learn something, the attendance cannot bound you. In fact, this course, this class is of like most senior students, like PhD and 4th year. It is not for first year or second year BTechs or so therefore I believe at this stage the students should have their own interest. So and accordingly they should attend, and they should encourage the teachers as well as themselves. And the attendance is just one kind of indication for the teacher that how many of you are interested and what is your interest content, that things will go accordingly. So let me just very quickly, I'll as I said, I'll take kind of a prompt, attendance, not a detailed attendance of everybody. So today is my second day. Quickly, I'll just take the attendance and quickly I'll come back to my lecture. So that we should cover more time for the lecture and less time for attendance. In fact, in our WebEx platform, we have a good advantage that your names are actually registered and it is noted down. Who are attending the classes, and those things, participants are basically, their names are actually noted down and it is included at our end. And that is also one plus point of this software. So again and again I repeat, it is not compulsory or it is not mandatory, or we're not suppressing it. Just do the class, attend the class. But at the same time, we encourage attend the class to learn something and to encourage to others and some embed your knowledge and ideas. Fine. So quickly, I'll just call the a few serial numbers, and you just respond me as usual. Yesterday you did. Serial number 10. Ayush. Ayush.
Present. I'm 10 present.
Ayush. Ayush, I could see your. It is showing Gomati Prasad, who is telling to me he is Gomati Prasad. Ayush Katiyar, I could not see. Ayush Katiyar, is it? Are you here? Are you in the class?
Yes, ma'am. Present.
Can you see your video? Your name is not coming. It is showing Nitish Kumar. See, whatever you will say, na, it will display in my front, right? So if he is not present, no problem. Ayush Katiyar. Roll number is 0.
Ma'am, Ayush is present. He has made it clear. He has written in the chat he is present.
No, but the point is what I'm trying to say. Ayush is present. The point is his box is not appearing to me. When somebody say the present, na, so the box will appear to me. It's not appearing here. Ayush. Okay, next is serial number 22, Modi.
Ma'am. Present, ma'am.
Modi.
Present, ma'am. Present.
Present?
Yes, ma'am.
Okay. Next, Gupta, 28. Gupta. Present or absent? Gupta is present or absent? Absent. Okay. Now I'll come to 36. Saurav. Absent. Fine. So, Agarwal.
Hello, ma'am.
Yeah.
Ma'am, actually, Mrityunjay is present in the class, but the audio, you are not audible to him. He is writing in the comment.
Yes, ma'am. Gupta is present.
Ma'am, he is telling that he is present.
Okay. I'll interact. Okay. Agarwal. Bijit Agarwal is present. Okay. Bipul. Vishal Meena. Vivek Kumar.
Present, ma'am.
I'm Saurabh Jaman, present, ma'am. 82 number.
Okay, Saurabh present.
Yes, ma'am.
Okay,
I'm present. 636.
fine. Okay, so no problem, no issue. So just for sake, I'm just. Okay. Vishal Mina is present.
Yes, ma'am. I am present.
Vishal Mina.
Yes, ma'am. Yes, ma'am.
Yeah, present. So okay, see, actually, let me tell you this. Anyway, the names are appearing in your software. Just for my for our records, we are taking it. But I don't want to waste more time on this. This thing, attendance and all. As I said, it is up to you. You should have some good kind of this thing. Your knowledge, you have to knowledge, and that's all. So you don't bother for this. That why ma'am is so. It's not like that. Our indication and our purpose, we are doing this, taking this. Fine. So let us start the class. So yesterday I was discussing the subject just for reminding a few students, PhD scholars, they joined newly. So this Smart Grid course is basically a 4-credit course. It has 3 lectures and 1 tute, and CWS and MT is 25, and ET end term examination is 50. So I sent this PPT end of my class, and I was here yesterday that what is this motivation behind it, so that I am interested to cover this course with all of you, and so nicely we can end off this class, and you can learn something at least, and I can share some thought process from my side, so that it will benefit for all of you. Fine. So India government, as I said, that smart grid is basically a vision. It's not like a packed kind of packing devices. Just it is available ready-madely in the market, and you just take it and use for your purpose. It is not like that. It's a kind of vision how the customers, how the utilities, and how the different companies, how they are actually planning. And most importantly, the major motivation behind this particular subject is, as I was discussing yesterday, let me just remind. In every class, what I do, I just recall what I have discussed in the last class, that as I said, that our major energy source is basically the coal-based generation, and it is almost around 55.5%. And our renewable source generation, belt is almost more or less, it is nearer about 23.24%. So therefore, our major contribution, energy contribution, is coming from coal. So we have to reduce that belt. Otherwise, it will be a very troublesome situation for all of us. And again, also I have discussed that our demand, mostly in the Asian continent, our demand is increasing exponentially. So this exponential increased demand, so we have to fulfill from some energy sources. So what are the alternatives? So we cannot go anymore for this carbon dioxide based, the fossil fuel based generation, because there is huge enormous carbon dioxide emission or carbon monoxide, which are very poisonous gas, and it spoils. There is an environmental change, and there is I think all of you know about it. What are the impact basically going to happen due to this carbon dioxide emission and carbon monoxide emission? And secondly, thirdly, I also discussed that there are 5 types of loads. Like we have residential loads, we have commercial loads, we have industrial loads, we have agricultural loads, and also we are going to renovate. It's a kind of replacement, I can say. Because in transportation, if you see that most of the the things, we are using the petrol and diesel concept, and from there 20 to 30% pollution is coming from the transportation sectors. So this transportation sector is going to be very soon to be replaced by the renewable powered batteries. So the electric vehicles, right? The electric vehicles, not only it will be 2 vehicles, 2 wheels. It is not only 3 wheels. It will have some 4-wheeler. It may be 2-wheeler. It may be 3-wheeler. There may be kind of trucks, bus, whatever. Planning for that. So how much it will be successful? Let us see in the next decade, coming decade, we will be just trying our best. So keeping all this in mind, and again I said that in India, our main problem is the peak energy deficit. The peak energy deficit means, suppose in the morning hour, basically our load demand is quite high, and the evening hour also our load is very quite high, because maximum residential loads and all the demands are basically on their loads. So therefore, to just have this mitigation, I mean, how to fulfill those peak demand. So that is also one crisis. Yeah. So there, the renewable source can act as a factor. If you have renewable sources like solar, wind, we can supply those demands quickly. Or even you have some battery storage systems, or you have some electric vehicles. I said yesterday also, the electric vehicle also acts like a as a load as well as a source. So when I need some energy, the electric vehicles can also, it should be in a position to supply the power to the customer, I mean the required places. So the main key renewable sources in India are basically wind and solar. And India targets around 100 gigawatt of solar and 75 gigawatt of wind by 2022. So I said by 2030, the India government is planning to integrate around more than 300 gigawatt of renewable generation. See, these are some of the figures and installed capacity of RES. This RES stands for Renewable Energy System Sources, like you can say, all India on 31st, 5th and 2020 in megawatt. We have the capacity of small hydro is around 4683 and wind power is around 37.75 megawatt, biomass, waste energy, solar. The total capacity, somebody will ask you that what is the figure, the amount of energy or power we are getting from renewable in all India basis, that is 87.38 gigawatt. So that means more or less we are getting 88 gigawatt of energy from all the sources like small hydro, wind, and biomass. This BM stands for biomass, power and cogeneration, waste energy, solar. So my question here is how we can increase this figure as far as the renewable energy is concerned. How we can increase this figure, that should be our target. Okay, so even it may be a solar platform, it may be a wind platform, or it may be a small hydropower platform, or it may be a waste to energy platform. Biomass from the waste products also, bio waste also we can produce energy. Okay, some tidal energy, so geothermal energy from the the surface of the earth, we have some heating effect, so from there we can also extract some energy, and from the tidal energy from the tide of the ocean, from there also we can extract some energy. So the point is, which are actually renewable in nature, the sources are renewable in nature, from there we should try to extract more and more energy. That is the first point. And second, the question, the subject I am just trying to introduce, the definition still I have not told to all of you. Still that is in clue, that is in a hidden form, that you will be just going to listen. What is this smart grid concept? Slowly I am trying to cover to all of you, that finally you will see the definition of the smart grid word itself. So this, what I'm trying to say, that these renewable sources are the main alternative sources to mitigate our problem or our requirements of the society as a whole and as a mankind as a whole. So and we have to basically remove the concept of carbon dioxide emission based plants. That should be our major goal. Okay, and in fact, now I'm just giving a small clue or some concept, some visualization slowly, that these renewable sources are very intermittent in nature. So intermittent means it's very fluctuating in nature. So you cannot say today you have good amount of solar energy, solar irradiance. Maybe tomorrow you will get the rainy day. Or today also you have very windy space, windy day. The wind speed is fine, up to 16 meter per second, 12 meter per second, 10 meter per second. But unfortunately, you may not get also wind in that region due to some geographical changes and environmental changes. So therefore, and this what I'm trying to say. This sources are very uncertain in their presence in nature, but you cannot say that they are not absent all the time. Of course, it is controlled by the nature. It's a climatic change and all. So geographical location, so everything affects. So you cannot say, certainly I am going to generate this much amount of solar from my solar plant. Of course, if your irradiance is better throughout the day, it is constant, it is steady, stable, then you will be, whatever your target of amount of energy you want to generate from the solar, you can generate it. But if it is not steady, the solar radiance is not sufficient, then you're not going to be able to generate that amount of energy or power what you have decided. So in that case, what I'm trying to say that these renewable sources are very intermittent in nature, and to accommodate this intermittent nature-based renewable sources or energy sources to the existing grid is a challenging task. It is not so easy because if while you are going to penetrate this intermittent nature-based renewable sources to the existing grid, definitely your grid should be the grid should be in a position to accommodate those energy sources. Our technology and our infrastructure, existing infrastructure, everything should be in a position basically to accommodate these energy sources, right? So therefore, what I'm trying to say to all of you that these are very uncertain in nature. The generation profile, the generation pattern, so everything depends on the nature. So nothing, at least the source is not in our hand. Am I correct? So all of you will be agreed with me that the source of the source from where they're getting the energy, the solar, wind, tidal, these are not in my control. These are not within our control. So only the thing is when the sources are available, we have the control how quickly we can generate the energy and pump to the required load centers or required grid centers. Okay. So that is the first and foremost understanding should be there between you and me, that you should be also agreed. The renewables are very intermittent and kind of uncertain in nature. I can say this is very uncertain. But at the same time, the forecasting, luckily we have a forecasting system. This forecasting can help us. At least we can have some vision for next 1 month, next 2 days, or next 1 week ahead, that what could be the weather condition, the weather condition. So accordingly, we have to schedule, we have to just plan that this is the amount of energy we are going to get from renewables, and these are the amounts of energy we are going to get some batteries, and these are the energy we are going to get from the non-renewable sources. So this is my small visions, and slowly as the progress, I can say keep in front of you many smart grid technology concepts which you will understand in a better way. So this is how the things go. Slowly today, I'll tell you, my talk today will be that so I am just going to somebody has written in the chat box, and see, when the class will be started, I will not be disturbed unless until somebody asks some questions. At the end, I'll read the chat box and I'll answer to all of you. And of course, everything I'll mitigate all the problems, you don't worry. Even when you are not suppose getting some link or some connectivity, I said I'll be with you, and at the end we can talk. Maybe extra class I can take. It's not a problem. So this, today I'll just tell you very clearly that what is the basic difference between a conventional grid and a smart grid. That concept, that may be a question to all of you. Just before, yesterday and today, I just told you the scenario of the energy. That's all in the Indian market, in Indian context, in the world context. But now I'll just in second phase of my class, I'm just trying to present to all of you that what is the basic difference? Why we are so much worried? Why we are so much hungry towards this smart grid concept? What's the need of it? In India and government also we have one mission. It's called Mission Innovation. You can write it also. You can also type the website and you can visit if somebody is very kind of passionate about it, energy sectors. So he can type this Mission Innovation. So in Mission Innovation, India is the leading country where many other countries, Canada, US, Europe, China, then you have the southern side and Arabians. And those Australia. So other countries also they're participating and they're going towards evolving the new technologies for this smart grid platform. So, and also apart from that, we have a smart grid worldwide, one smart grid federation. So there, India is also one of the member. So the point is, what I'm trying to say that every goal ends at one point that what could be the possible ways out for smart grid technology? What could be the possible ways out for getting my energy from the renewable sources and penetrating to the existing grid and supplying to the customers? That's all. That is the main goal. So basically, whatever we are just studying and analyzing based on anything, that ends only one thing, that how a qualitative power we can supply to the customers. So this today I'll just tell you what is the difference between this conventional grid and the smart grid. One student he was asked me in the last class, the last semester, that we have already grid, we have conventional grid. Why again we are just worried for the smart grid? What is the reason? That is what I am today going to explain to all of you. So these electrical power grids are the largest man-made grid. You have 9 national grids. So this side is basically the southern national grid. This is the western national grid, and this side is the northern national grid, and this is northeast national grid, and this side is your eastern national grid. There are 5 national grids in India. So all are basically interconnected. So this is a very huge man-made electrical network. Suppose, to transfer power from the northern side to the eastern side, you know how much distance you have to basically progress. You have to basically progress like 200, 2000, 3000, 4000 kilometers. At least from Odisha to this Roorkee or Delhi, it's almost 2200 kilometers, 2000 kilometers, more than 2000. So if you transfer that amount of transmission lines or you have to push power through the transmission line, so huge losses are going to be there. And of course, one more point to remember, that you have to also invest money for erecting the transmission infrastructures. So therefore, let us have some localized generation, and that localized generations are going to be available to the localized nearby loads. I'll tell one by one for that. So this is the celestial view of India at night, how the loads are basically available. So coming to the direct shot, that the main demerit, 3 points you have to remember, or you can write down in short in your notes. As I said, requested yesterday that all of you please maintain one notebook for this. Just write down the points clearly, that what are the points I'm just explaining in the class. Sometimes some extra points also you have to also write down, which are not available in my PPTs. And kindly just write in short form. You can write also on the notebooks also. And maybe you can interrupt me in between the class, and in the end of the class also you are allowed to ask any questions. You all are free. I become very happy, and that is my way of taking the class, that if I am somewhere wrong or right, you have all the rights to point me. You have all the rights to interrupt me. Okay, I never mind. Rather, I encourage to the students. So please, ask questions. If you ask questions, then you can understand the subject better way. So the first disadvantage, I'll discuss you with 3 points, 3 major. I said today I'll discuss with you the advantage and disadvantage of the existing grid and advantage of the smart grid and finally the definition. So these are the discussion points. So the first disadvantage of the existing grid is what? No large scale storage in the system. Now see the blue font line, this one. So no large scale storage in the system. So that means we don't have storage. See, actually, initially before 20 years back, I have seen that we have a national, generating station. Look, centralized generating station, that is NTPC, or some large hydropower plants like in Uttarakhand or in other states like Himachal. So there we have the Tehri and other national hydropower plants. So in South also we have national hydropower plants. So it's a centralized power plants from where the power is basically, it was driven and it was just going to the nearby or maybe other states or some different states or different corner of the country. So that means the power station was very far away from the load centers. That is what I am trying to say. So it is a unidirectional flow of power. What is that? It's a unidirectional power flow and there is no storage. Suppose there is a low demand of power, you have excess power generation, but there is no storage for that. How to store it? Because if you store it, the power, then you can use for the next moment. So the storage was a big problem. But fortunately, the Nobel Prize, the person who got lithium batteries. Today we have lithium ion battery, we have lead acid batteries, we have flywheels, we have supercapacitors. We have also one more pump storage power plants. So where different thermal storage power plants. So we have different types of storage devices available in today's days. See, this storage devices which are available now, I think that it is a very small thing. No, the technology which are developed to basically to integrate those storage devices in the existing platform, the existing grid. We need some good technology. That technology is smart grid technology. So initially, coming to the point, the main first disadvantage of this existing grid, AC grid, now we don't have DC grid. Now I'm talking about the AC grid because our supply is AC, 230 volt at the end of 50 hertz. And the second point, unidirectional flow of energy. The power flow, now as I said, our power generation was centrally and the power flow was just driven to the respective load centers, right? So through the substations, right? We have ESB lines, big substations, then you have transmission lines, then you have distribution lines, then the load centers, load points. So therefore, the power flow, the second point is unidirectional power flow. Yes. Now, the third point is very, very important. That is no real-time communication and information flow between the generators and customers. So, it is, all of you also will be agreed. This concept only introduced before few years, and due to the advanced communication infrastructures and good computing facilities like good super computing facilities and good computers. So this, the load center was somewhere else and the generating stations are somewhere else. So the communication between the load centers and the generating centers, it was nil. There is no communication between them. As if the generating stations are the king and the load centers are the servant. So the load centers are completely dependent on the generating stations. Whatever the generating station will say, the customer is going to accept it. This is our duration of the power supply. Okay. This is our per unit cost. Okay. And this is the bill you have to pay. Okay. So sorry, hands off. So now at this smart grid era, this kind of the generating station is the king and the load centers are servant. That concept is not existing. So if suppose, for example, I'm just giving you a quick example so that you can just think about it. Just near to my home, I'll talk about it more in detail when the course will advance. That if I have some solar park, of kind of 10 megawatts, 20 megawatts, small solar park near to my house or building. So like 10, 12 residences quickly access, maybe 100 residences, they will access the power from the nearby solar park. They are not going to be dependent 2,000 kilometers away NTPC generating stations. If any blackout, any brownout, any kind of sudden, loss of power exists, then what will happen? I have seen in my one eyes in our villages for month and month we didn't get any supply because that something is gone and something is burnt. The transformer is burnt. The distribution line is fell down, and there is nobody is to take care of it. Shortage of power. What is this? So in that way, that kind of philosophy is not anymore existing. So therefore, my question is to all of you that my point to all of you is that the no real-time communication information flow between the generators and customer, even not only the information communication flow, data flow, but also at the same time there is no power flow between the loads to the generators. From the generator to the loads, the power flow was there. But now in the smart grid era, we can also have one more combination that the customer can always speak to the utilities, and also the customer can also has the power. It can also supply the surplus power to the utilities, or maybe some nearby loads, or maybe to anybody else. It can also send. So this kind of freedom, flexibility, I can say this is flexibility, is only possible in this era, smart grid technology. And yes, of course, the last one, the demand side control is almost non-existent. Demand side control means what? This last one. You see the last one. The demand side control means, what is that? The demand, suppose I need some, let me tell you, when I'll go for smart grid, I'll tell you very good examples of US pattern of energy savings. There I'll tell you how the customers are basically they have all the options. Like in a mobile phone, you have all choice, whether you can go for Airtel, you can go for BSNL, or you can go for Geo. So whatever the SIM, which is giving less offer, good package for more days of talk time and a good package of internet. So then you can purchase from there. So similarly, the electricity market is going to be like that. The customer can choose from where he or she wants to purchase, and he is not bound to take supply from the existing national grid. Not like that. So the customer has all the flexibility. The demand side control, and again, the cost. Suppose the Airtel customer, suppose they can seize your any faulty you have, the SIM can be seized. Or the supply, the signals can, whatever, they are doing some kind of, control over the customer. Similarly, the utility has also the power to control the customers. So this demand side control is almost non-existent in the present grid, except from some load setting concept. So therefore, what I'm trying to say or convince to all of you that the grid has many disadvantages. So the second disadvantage I'll put in front of you, the blackout. In power outages in India, in 2012 there was a national grid blackout. And let me tell you just for 2 minutes that what is this blackout? What is that term? Maybe it is a new to all of you, and you can also know it. That in 2012, July 30th night, there was a line which was connecting Bina to Gwalior. The Bina means it was in the northern side, western side Gwalior, and this in between the north and west side there was a 400 kV line which was actually overloaded due to the excess power drawn from the northern side customers. So this line was overloaded, and that concept we call it as, you can write it in your note, load enforcement problem. So when some line is overloaded, we call it as load enforcement problem, and the relays which are basically the line which is basically protected by some protected devices, and one of the major devices I can tell distance relay. So that relay was basically maloperated due to the load encroachment problem. Zone 3, you can write it. And in fact, if you need more detail, I can send some, PDF files for this. And there you can see the picture how it had happened. So when that line, protected device was maloperated due to the increase in the load through that particular line, the line was tripped, the line was opened due to the, the relay failure, the maloperation. The breaker was open, the line was open, out of service. So what happened? That line was carrying definitely some 400, exact figure I have not remembered, 400, or because it's a 400 kV line means obviously the carrying power capacity is the range of 400 to 200 or 600 megawatt, not in kilowatt. So that amount of power, what will happen? According to KCL, the current, the power and the current will take some another path because it is interconnected network. It is not a single line. So many lines are connecting to the western side to northern side, from western grid to northern grid. So other lines started carrying the power. Other lines becomes they become overloaded. Again, those lines tripped. Slowly, all the lines are basically tripped. And suddenly, what happened? What happened? Suddenly, inside the northern side, some generating units, they have to be shut down because there is an imbalance between the generation and the load. If you not stop or shut down the generators, what will happen? Then there will be some problem in the stator and rotor windings. So therefore, there is shutdown of the generators in the northern side. Okay, and there is a prime mover movement, but there is a loss of energy, electrical energy. So there is an imbalance between mechanical and electrical energy. So suddenly you have to stop the generators supply or its movement or its movement. So therefore, sudden generator shutdown means there is a blackout. So whole northern grid and northeast grid together, they're actually under a blackout situation. Blackout means there is no supply, no generation, nothing. And you remember what kind of situation it is. If suppose in your room or office at your home, for 1 minute the supply is not there, how do you feel? How do you feel? You can't tolerate for a minute. So for 2 days, they're under blackout situation. And a lot of money was actually lost. And a lot of people are in troublesome. We call it as critical loads and some priority loads and non-priority loads. The critical loads are those loads which demands the supply as quick as possible. Right? So critical loads means you have your hospitals, you have the flight takeover system. Like suddenly the flight has to take, so you cannot stop the supply over there. Suddenly the supply is off means you should have some backup supply for that. And some hospitals where the operation is going on and the supply quickly is off, so what will happen to the patient? So you have to keep the supply on by backup. So the same example I'm just telling to all of you it's a very real problem in India, not in outside, not in any other country. I'm talking honestly. So during this Delhi Metro, during this period, it was isolated from the main grid and it has been powered by the backup supplies of the genset. Genset means diesel generators. So that diesel generator was automatically switched on and the metros are on. So what happened? What I'm trying to say to all of you in a very short, because it will take long time because lot of investigation have been done and many task force forces have been they are engaged by the government of India that you just investigate what is the problem, why it had happened, where is our shortcomings. In India we have many shortcomings, not a single shortcomings. So we have many shortcomings: poor maintenance, poor infrastructure, aging infrastructure. So many things are there. So, people who are just careless. So this is my desired load, but I can use 2-3 ACs, I can use 2-3 heaters without informing to the authority that, in a particular area, the load will keep on increasing. What will happen? Suppose 1,000, I can give you one example. There is a political authority. They go for one, some kind of this preaching, they're from political parties. So thousand people, they are just sitting and they are just tapping the energy from the nearby lines, and lot many loads are running over there. So what will happen? That's extra. It is not noticed. The notice has not been reached to the operator or to the substation operator. So many things are there which actually we violate without our knowledge. So this is actually lack of knowledge and lack of maintenance, lack of on-trained manpower, and lack of aging infrastructures. So many things are there. But anyway, so this is the real true fact I'm just sharing with you, all of you, to motivate all of you that why this smart grid is very, very important nowadays to avoid such kind of thing. This kind of blackout actually that happened in US. Therefore, from there actually this word smart grid has been originated. That I can show you very quickly after maybe one slides. So this is how the things had happened in India. So we should avoid. So millions, billions dollars. I mean monies, rupees actually wasted for last 2 days. You see many companies and many good industries. So they are stopped, halt. So supply was totally stopped. So and many lives and many losses are. You can't imagine. And the cars and in the the many things and traffic jam. So many things had happened. So anyway, so we have to overcome such kind of large disturbances, and only it is possible through this smart grid technology. And this is the your interest point where I landed here. As I said, I'll tell you very clearly that what is the basic difference. The concept, the difference between the large AC system which is existing now throughout India, and now what is the demerit of it. So the first one is the limitations of this large AC systems are seen by this picture, my right side picture. Along x-axis we have size of the interconnected grid, and along y-axis we have benefits and efforts. Okay, so this is quite a good picture to understand it in a better way. What I said just I'm just explaining to you, but this picture speaks more than write-up. Every time remember, while you are just prepare the PPTs on online mode of operation, either you can write or some pictures. So pictures tells more. Pictorial informations are more informative than the writing sentences. So this picture, what I'm trying to convince you that I'm trying to inform you that along x-axis I have taken the size of the interconnected grid. Size means what? Number of buses, number of lines, power handling capacity, voltage level. It will keep on increasing. Then what will happen to my benefits and efforts? So initially with size, my efforts are fine. See here, this curve, red one and this blue one. So it has an optimum value in between. In between there's optimum value. So whatever efforts you apply, some good benefit you will get. This red one is the efforts, and the blue one is my benefits. So when I give this much of effort, so I'm just getting this amount of benefits. My benefits is better. So obviously, so every company or anybody doesn't want that my effort is 10%. My effort is 80%, but my benefit is 10%. Who wants it? And everybody wants more than. This is my effort of 80%. 30%. So my benefit should be 60%, double of it, isn't it? That is what is our aim always. So therefore, here you see at the end when the size of the grid increases. So here you could see that even if your benefit is quite high, again your benefit is a good amount, but the gap is very less. Almost they are close to each other. Whatever the benefit you are supplying, suppose 80% effort, you are getting almost 85% of benefits, not more than that. So that means as the size of increase of the grid size will increase, there is some losses, there is some cost involvement, there is some unavailability of the power, there is no availability of communications, there is some other factors which are involved, which actually shrinks your benefits. Okay, so this is a very important insight we have to understand, that some researchers, they're trying to say why you are interested for smart grid. You tell me. So this is actually a lot of analysis are there. Just in brief, and salient points, I can say cream part of the analysis I am just putting into this, because this subject covers many things. So it's a very analytic subject and also mathematical, and at the same time logical. So we have to understand. So that's a higher end research oriented subject. So you can understand, you will be overwhelmed and you will be encouraged to continue your research or to do your job style or something, you'll be motivated. So these are some of the very true facts I just kept in front of you in terms of these pictures. And the left side, I have some technical terms. So technical terms means the researchers, they are doing the research on this. Voltage stability is a problem. Reactive power problems are there. Steady state stability is there. Transient stability. Subsynchronous oscillations. The load flow problems. Management of congestion. Oscillation stability. Blackout risk I discussed with all of you. Interaction between the power system in terms of physics. So at last, I just want to tell to all of you that when the synchronous system is very large, advantages diminish. So therefore, it is not a quite today's date. It is not quite convincing that we will be dependent fully on the existing AC grid. No, that is not possible. That cannot mitigate our demand, certainly. So therefore, we need some flexibility. That flexibility, why we need? Because somebody say that, it's a pressure. It's a pressure. It's a pressure. I have written here, pressures on the present grid. There is a pressure on the present grid. So therefore, we need this flexibility in the grid. So that flexibility is only possible by bringing smartness in the grid. So see, actually, the idea, the technologies are evolving. The concept of, see, I'm just, I can tell you a good example to all of you. So in my home, I have some TV of 55 inch. Earlier also I have some TV like that in big size. The point is, it's a smart TV. What is smart TV? I can have interconnection, internet connectivity. I can have the Bluetooth connectivity, wireless connectivity, with wire connectivity. So many options. I can open the PDF. I can open the Word file. I can connect my mobile to the TV. I can have a video conferencing through my TV. So what I'm trying to say, the same thing, the concept is there, but only thing is the features, the availability, the flexibility has been increased. Okay, so similarly, our grid is there. See, V is equal to IR, the KVL, KCL, nobody is going to change it, the basic concept. But the point is, depending on our requirement, depending on our challenges, we have to have some good technology for this. With the conventional technology, we cannot sustain anymore. Therefore, the first is increasing grid size, complexity, demand growth, increasing energy trend, changing load flow hours, bulk power generation, we have to stop. Because with the bulk power generation, we had lot of losses. It is also written in the industry personnel. I'm not telling for simulation or some paper-based information. 20 to 30% losses in the transmission lines while transmitting the power from the station, generating station to the load center. So why should I bear this if I have some other facility? If I can get the power near to my home. So obviously that 20% will be merged. It will be asked from the customers. Otherwise the utility, from where it will get the cost, the benefit. Okay. So with a lower cost, I can get the power from the nearby stations. So bottlenecks and overloads that I discussed, and variable infit. So those concepts, those are problems which are just surrounded us. So these are the problems which are surrounding our grids, our system, electrical system. So those are basically the driving forces for all of us. An efficient, reliable, secure grid we need. And along with this, one more word I will add, that is a sustainability, when I'll come to the definition of the grids. In US, when Barack Obama was the president, in 2003 there was a blackout, and from there they thought of like India. So in 2012, so there was the largest blackout in India, so in the whole world. So similarly, our government has planned to have a very good policy for the renewable sources integration and backup powers and some islanding operation of the systems and battery storage systems. So therefore, these are some of the points in US. And keeping in that mind, so this is a definition of this, the smart grid. Information technology, communication technology to provide better grid performance to support the wide array of additional digital service to the customers. The definition from Energy Future Coalition. So what I'm trying to say to all of you, whoever sitting, the students, to all of you clearly listen to this. So I'm the end of my first part, that what is the definition of smart grid? Somebody asked you. It is nothing. In a very simplified way, Global Smart Grid Federation has given some definition. Then Energy Future Coalition has given, Energy Department of US has given one definition. Indian government is giving one definition. China government is giving. But overall, if you just add together the main, only one line definition I can give from my side, my understanding is that there is a marry between, and one side is the existing grid, okay, and other side is your very much dedicated communication infrastructure, information technology, and of course the intelligent sensors strategy. Remember, you can write it if you could not and get it. You can write it. One side is the national grid, existing grid, and other side we have ICT. We call it as ICT, in very dedicated, advanced communication technology. Again, you have advanced information technology. Information technology, you are understand, I think all of you, the computer facility, computing facility, coding, whatever you can say. And again, along with that, we should have very sensible, intelligent sensors and automated control strategy. These are 3 points on this side, right side, left side is the existing grid. When these things, two things marry together, so that is the generation of the, or you can say evolvement of the smart grid. Nothing else. Smart grid is nothing. So that means indirectly what I'm trying to say, we are not moving away this existing grid. Existing grid is there. So without the base, you cannot do anything. But we are adding something new, some intelligence, some advanced layers of technology. So to make our existing grid smart. So therefore, this smart grid is like that, which will help us efficiently deliver sustainable, economic, and secure electricity supplies to the customers. So with help of this, see, this is not no imagination, no theoretical concept. This is a reality. So therefore, what I'm trying to say to all of you, that smart grid really is an electrical grid that uses computers and other technology to gather, act on information such as information about the behavior of suppliers, customers in an automated fashion. Improve the efficiency, reliability, economics, and sustainability of the production, distribution, electricity. So see, actually, finally, what is our aim? Somebody will ask you, even then we are talking so much that you will just add a dedicated communication layer, this, that, intelligent sensor. What is the aim? So our final aim is we should have very efficient, reliable, economic, and less cost effective and sustainable grid or supply system to the customers. We have to satisfy the customers. So what is this? Then if this is a definition, what is the characteristics of the smart grid? When something is generated, it has taken birth, what is its characteristic? How it looks like, or how it behaves? It is intelligent, green, efficient, accommodating, motivating, opportunistic, quality, resilient. So many characteristics are there. So if I seek to explain one, it will take at least 4 or 5 classes. But in single class, I can say to all of you that this smart grid has a good feature, accommodative. So it will help you to accommodate whatever the renewables you have. You penetrate to the existing, no problem. Whatever the storage device you have, just you penetrate to the existing grid, no problem. That is the nature of accommodative. But in a conventional grid, if you try to accommodate the renewables and storage, that is not possible. Because that feature technology you have to embed, then only you will integrate. So that technology, intelligence, basically the smartness of the grid. So that it will allow the renewable sources without any problem in the system, storage in the system, electric vehicles in the system. So it is self-healing, self-resilient in nature, and automated operation will be there. So there are so many, and efficient, of course. So these are some of the self-healing, self-monitoring, secure, cleaner, and cleaner obviously because we are trying to reduce the fossil fuel-based generation and help customers better control energy in their homes and businesses. This one I promised you from the beginning of my class. So we have to wind off now the class. It is time now. But I just want to share with small glimpse of this concept. And slowly you can understand many other features also. That in US, basically, the customer has a card, energy card. Card, I think all of you understand. So suppose they have to punch the card with different terminals of supply in their home. So they have to supply 1, supply 2, supply 3. So they're punching the card means the supply 1 means the supply 1, agency 1, utility 1 will supply the power. Let us say from 6 to 7, supply agency 1 has low cost. So they have to take the power from there. As it is simple, very simple. Let us say from 8 to 9, I got a message. So these are the company's comparative statements and also price base. So I have to insert the card over there. So like this. So this is, the customer has many, opportunities and flexibility or some, options you can say. Yeah, and he has the ideas how to choose the energy supply from where with the low cost or some good, the quality, whatever. So these are some of the few discussion I held in front of you. There are many things that are beyond it. People are doing good research in this direction, even in US, India, Canada, Europe. They are just in a very higher manner. So these are some of the things, and as I said from the beginning, smart grid is a vision, not a product. So smart grid is not a product or service. It's a vision that we have to explore, and we have to find out what are the keys and ways out. So depending on the utilities perspective, what is the vision of the smart grid, and from the customer point of view, what is the vision? So of course it will be different. So that's why, therefore I said it's not a constant product. So that the utility will take it and install inside its premises, and the customer will just purchase and it will just install inside the premises. No, their visions depending on their utility requirement, it will be different. Smart grid technology. So today class is this much. If you have some queries, I'm ready to take questions. This much is today from my side. Any questions, students? Any questions, students? Anybody wants to ask any questions? Yes. If you have some questions, I'll be answering your queries. Otherwise, so today we'll call the day. We'll stop here, and again we'll meet tomorrow. One announcement to all of you. Kindly just note it down. And I think after this I'll share my my Excel sheet to all of you. You have to be divided into 3 groups: B1, B2, B3 for the tutorial class. So tomorrow, Thursday, 2 to 3 o'clock, B1 group will come for the tutorial, and Friday we have 3 to 4, B2 group will come, and Friday again 4 to 5, B3 group will come. So all the PhD scholars I request to attend at the B3 level. All the PhD scholars who have joined for this course, so they have to, and again, whoever the BTech 4th year students, they have joined newly, so they have to come again in the B3 group only. So it is a kind request to all the BTech students who have joined or going to join, please mail me together all your mail ID, because from the beginning this group ID has no, your email IDs are not included in the EN has 672. So therefore I need your mail IDs. Then only I can send the link and you can join for the tutorial class as well. So yes, somebody written in the chat. I'm just reading it. Let me read it. Ma'am, sometimes mic doesn't work on laptop. Like today I was said present. So, but why please make me present? Yes, of course. Don't worry. I can assure you at this point 100% attendance to you. You don't worry for attendance. And honestly speaking, I am that category that I bother the students for as far as the attendance is concerned. I am very happy if all of you will come and present in my class. Even I could not see all of you, but still I can list your names that have a very good session, enjoyable session for this semester.
Hello.
Yes, please go ahead.
Hello, ma'am. Tanmay this side.
Yeah, please go ahead, Tanmay.
Yes, ma'am. Ma'am, actually, few students have problems connecting to WebEx link. So, is that feasible to you if you conduct the same session in Microsoft Teams? Because
see, actually, same thing will happen if somebody cannot see. WebEx is the easiest one. WebEx is the easiest platform. It doesn't need anything. Just simply go and click the join the link. That's all. So WebEx and Microsoft Team on the same platform. So if somebody cannot open WebEx, so how can you assure that he can open the Microsoft Team?
Ma'am, actually few students were telling me that Microsoft Teams are working just fine with them, and they don't have any problem connecting to it. So,
Okay, fine. Then I have to go for this for next week onwards.
Okay, sure, ma'am. Sure.
This week I'll go with WebEx. So I'll just explore, and I'll maybe next week onwards, Monday onwards, I can go for Tuesday. I can go for Microsoft Team.
Okay, sure, ma'am. Thank you.
So same platform, but only thing is you have to be present. That's all. So any queries from students? So that was okay. I too wasn't able to answer your attendance. Okay, no problem, Harshit Yadav. So I'll take care of this point. And as I was telling to all of you that the group 1 will be B1, and then B2, and then B3. So in the B3, if any fourth year BTechs are present, please tell them to whoever interested, see the last date of the registration of the electives or courses. See that before that you send all your email IDs to me, and who are interested, and also tell them to email with a request so that I can revert back to them that I am agreed and you are allowed. So these two things will work out. So what will happen? I can add them so that they can participate at least in the class and tute. They should not miss the class or tute class. And third point, all of you, I request for tomorrow class tute, you should have to have MATLAB installation in your laptop or desktop, not mobile phone. So because we have to do everything in MATLAB, so MATLAB codes and Simulink are essential. So the TAs will explain to you in detail first 1-2 classes, and then they will take you to the tutorial sheets, whatever the experiments we want to do. So this is all about from my side. So we have divided into 3 groups. I am just dividing the groups. Let me just stop this sharing, and I am just putting in front of you again the sheets. I'm just sharing with you my Excel sheet, and I'll just tell you who are the students in the B1 and who are the students in B2 and who are the students in B3 group. So please note down. So I'm sorry for the late, because I could have stopped my class early. So there are 53 I could see here presently, 53 students. We'll go for 2020. The first up to roll number 20 will be B1, and then up to 40 serial number will be B2, and then from 40 to 53 will be my B3 group. And other PhD and any other BTechs are coming up, so they will be in the B3 group only. Is it okay to all of you? Is it okay to all of you?
Can you repeat the timings for B1, B2, and B3 group?
Pardon, this is Thursday. Tomorrow, B1 is for 2 to 3 o'clock, 2 p.m. to 3 p.m. And for B2, it is, maybe I can mail to all of you, okay? In my email ID, EN672, I can mail to all of you those time slots. And again, for B2, it is Friday 3 to 4, and B3, 4 to 5. Is it okay?
Yes, ma'am. Thank you.
Okay, so thank you all. I stopped my lecture here because already I exceeded the time. Have a nice time. Have a nice day. Take care of you, and be motivated, and don't take tension that what to do, how to do. So any problem, we will solve it, sort out, because it's a so bad situation, pandemic situation. We will cooperate. Don't worry. Thank you all for attending the class. Bye bye.